Well, hello. So let me just move something that you can't see. Move that to the side. Okay. We are in section 10-2, which starts on page 628, simplifying radical expressions. Why did I take my glasses off? I don't know. Alrighty. So a radical expression, something that contains a radical. Big surprise. The product property for square roots. Product. How much space do I have? Product property is if you have something that says it's the square root of a times b, well, that you could split this up and say that's the square root of a separately times the square root of b. Okay, and the opposite's true. If you're multiplying two things under a radical, you can square root of a times the square root of b. You can combine them like that. Okay. Um, so if we had something like, for example, the square root of 4 times 9, that equals the square root of 2. No, hold on. Yeah, bad teacher. That's the square root of 4. God, what am I thinking? Square root of 4 times the square root of 9, which you all know the square root of 4 is 2, and the square root of 9 is 3, which equals 6. And that is not going to shock you, no, because you also know that the square root of 4 times 9, well, 4 times 9 is 36, so the square root of 36, which of course equals 6. That's just to make the point that this is true. All right, because that 4 times 9 is 36. You know that that's correct. So square root of 4, which is 2, the square root of 9, which is 3, 2 times 3 is 6. It works. Okay, so when you are simplifying square roots that are multiplied, and I'm just going, oh, the bells, I bet you've missed those. If they say something like simplify the square root of 80, then we can just break this down into what's called its prime factorization. So that's going to be the square root of, well, what's 80? 80 is 16 times 5. Yeah. So that's going to be 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 5. So that equals the square root of 2 times 2 is 2 squared. Those are those two. Times the square root of 2 times these two is 2 times 2 is 2 squared. Times the square root of 5. The reason why I did it that way is because the square root of 2 squared, that's a perfect square. It's 2, right? 4. 2 times 2 is 4. So the square root of anything squared, like the square root of x squared is x. Okay? So the square root of 2 squared is 2. So that's going to be 2 times 2 times, you can't do anything with this. That's going to be times the square root of 5. Well, 2 times 2 is 4. Square root of 5. That is as simple as you can get it. So a simplified radical expression is one where you can't take anything outside of the square root sign anymore. All right, that there's no perfect squares in here anywhere. All right. A little quicker. 80 is 16 times 5. 16 is a perfect square. Square root of 16 is 4. So this is 16 times 5. Okay, the square root of 16 times square root of 16 is 4. I already said that. Anyhow, I'm just rambling. So what if you have variables in here? Oh, hold on, I'll do another one. So I'm just taking this straight out of the textbook. So if we have the square root of 2 times the square root of 14, Well, that is equal to the square root of 2 times the square root of 2 times 7. So that's going to be the square root of 2 times 2 times 7. See where I'm going with this? 2 times 2 is a perfect square. That's the square root of 2 squared times the square root of 7, which is 2 root 7. That is completely simplified. And lastly, for this, what if you have some variables in here? They have, the next example is the square root of 90 times x cubed y to the 4th z to the 5. Well, 90 is going to be 2 times, in what's called prime factorization. Prime, so I write these in terms of primes. 90 is, well, that's 9 times 10, and so 9 is 3 squared times 10. So that's going to be, let's see, that's 9 times 10. 10 is 2 times 5. 9 is 3 squared times 5. So 2 times 5 is 10 times 9. That's prime factorization. This, I can split this up into the perfect square of x squared times x. X squared times x, right? X squared times x is x cubed. I did that because this is a perfect square. That's a perfect square. Y to the 4 is already a perfect square. Z to the 5 is z to the 4, which is a perfect square. Z squared times z. This is all under the radical. Now I can simplify that, and anything that's a perfect square, I can take the square root of 3 squared is 3. The square root of x squared is x. The square root of x to the 4 is y to the 4 is y squared. The square root of z to the 4 is z squared. And anything I didn't take out is still under the radical. So I can't do anything with the 2. Can't do anything with the 5. I have an extra x here. And I have an extra z. Again, where do these things come from? This 3 came from the square root of 3 squared. This x came from the square root of x squared. This y squared came from the square root of y to the 4th, because that's y to the y squared squared. Yeah. This z squared came from the square root of z to the power 4. This 2 came from there. That's the leftover. That 5 came from here. That x came from there, because I can't take those out. And that c came from right there. All right. That is almost simplified. There's one more thing I can do, right? So 3x y squared z squared, because 2 times 5 is 10. So 10x times z. Alrighty, how much time do I have? Oh, let me see. You know what? I'm going to split this up into 3 different videos, just to be on the safe side. So that's the first one. There's 3 different sections to this section. There's the product property. I'm going to do the division property here in just a second, where the quotient property, excuse me, because we have to rationalize a denominator, loads of fun. And then we need to talk about conjugates, which is also loads of fun. I'm going to stop this one and save it.